Section 6 of Unit 5. This section would introduce you to the various principles of radiation detections. By the end of this session, you should be able to explain how to detect radiations with the various techniques. Let us look at how to detect radiations. There are several handheld laboratory instruments that can be used to measure radiations, and they can also be used to detect radiations. The most common ones are the Geiger counter with Geiger molar tube or probe. The Geiger molar tube is a gas-filled device that creates electrical pulse when a high voltage is applied to it, and its radiations interact with the walls or the gas in the tube. So this pulse that is created is converted to reading, which can be read on the instrument meter. So if the instrument has a speaker, the pulse also gives an audio click which can be heard. Some common units in which the radiations are measured is the Röntgen per hour, that's R per hour, the milliroentgens per hour, MR slash HR, the rem per hour, the millirem per hour, and count per minute. Next is the micro R meter with sodium iodide detector. So when radiations interact with solid crystals of sodium iodide, it creates a pulse of light. This pulse of light is converted to an electrical signal by a photomultiplier tube, which gives a reading on the instrument meter. The pulse of light is proportional to the amount of light and the energy deposited on the crystal. Now, if the instrument has a speaker, the pulse also gives an audible click, which is a useful feature when looking for a lost source. The micro R meter with sodium iodide detector can provide information on gamma ray energy and also identify the radioactive material. Some common units that are used are the micro Röntgen per hour and count per minute. Another instrument for detection of radiations is the portable multi-channel analyzer. So it is a sodium iodide crystal and PMT coupled with a small multi-channel analyzer electronic package. The portable multi-channel analyzer employs gamma ray data libraries and automatic gamma ray energy identification procedures to automatically identify and display the type of radioactive materials present in a sample. The fourth instrument that we shall be looking at is the ionization chamber. The ionization chamber is an air-filled chamber with an electrically conductive inner wall and central anode and a relatively low applied voltage. We shall delve more into the ionization ion chamber as we move on. Let's continue with the ionization chamber, and this is how it's able to generate current. The ionization chamber has an air volume. So when primary ion pairs are formed as a result of the interaction of gamma radiations or X rays within the chamber walls, the central anode will collect these electrons and a small current is generated. So this in turn is measured by an electrometer and it is displayed digitally or on an analog meter. The instrument must be calibrated properly to a traceable radiation source, and they are also designed to provide an accurate measure of absorbed dose in air, which through appropriate conversion factors can be related to a dose in tissues. It's good to note that because most chambers or most ion chambers are open air, they must be corrected for change in temperature and pressure. The common readout units for the ionization chamber is the milliroentgen and Roentgen per hour. These are a list of other counters that are also used to detect radiations, which I would want you to read further about to get more understanding on. The neutron REM meter with proportional counter, the reading detector, the liquid scintillation counters, the proportional counter, and then multi-channel analyzer system. This is also a self-assessment question which I have added for you to try your hands on